right, we're going to go ahead and get started. I want to welcome everyone to the On the Right Track Educator webinar hosted by the Arizona Game and Fish Department. My name is Eric Proctor, and I am the Wildlife Education Coordinator for the Arizona Game and Fish Department. Let me tell you a little bit about myself and the department, and then we'll tell you a little bit about how this webinar is going to work a little bit. So Arizona Game and Fish Department, if you're not familiar with us, we are the state agency responsible for managing Arizona's native wildlife species. And so it's our job. A lot of people interact with us through hunting and fishing. We're the one that distribute the hunting and fishing licenses and then enforce those regulations in the field. But we are not only responsible for those animals that you can hunt and fish, but for all wildlife found in Arizona. And so those that you can't hunt and fish as well, the endangered species, the threatened species, and those that just don't fall into any of those particular categories. I am the Wildlife Education Coordinator, and in that role, I serve sort of behind the scenes in the formal education environment. I work with you guys as teachers primarily, with professional development, stuff like this, the online professional development, the in-person professional development. I also do curriculum development as well. So finding unique ways to bring wildlife issues, wildlife concepts into the classroom so that they can be used by you as an educator so that your students can learn. I've been in that role for about 10 years now, and prior to that I was a former middle school science teacher primarily, although in one of my districts I did have to pick up social studies as well. Let's get this presentation started. Today obviously we're going to be focusing on tracking and how do we track wildlife. And we're going to start with a historical look first of all and look at how we used to do tracking and how we kind of still do today. And I like to primarily refer to it as a traditional tracking method. And this is primarily where you try to identify tracks and other signs that animals leave behind, such as paw prints, scat, hair samples, digging holes, leaf bites, all sorts of different things that they might leave behind that tell you that an animal was there, and they're clues to tell you what animal it was and what that animal was doing. Now, traditional tracking techniques have been used for all of humankind, basically. It just required skill. It didn't really have any technology that was required to use it. You didn't need anything special as long as you had the skills, and obviously the more you did it and the more you understood about an animal's behavior and their natural history, the easier it was to track. Okay. While this is still an old-fashioned, for lack of a better term, technique that was used it is still something we use today. We'll talk about the technology we use in just a minute, but I did want to focus on this because it is important. This is the basis for just about any animal study you're going to do, because you don't want to jump in and use all of your other expensive equipment and all of the other resources that you have until you can verify that the animal is there and it's the animal that you're looking for. So everything still as a base comes down to identifying signs of animals. And as such, it also makes a really good opportunity to bring this idea into your classroom and can actually lead to some really good inquiry techniques. So I'm going to give you an example, and I know some of you have seen this before. This is a sheet that we use, and I'll show you where you can get this sheet and actually how you can make this sheet in just a second here. But it's just a bed sheet, just a simple white bed sheet, and all we did was we took some paw prints from some animals, and these are latex prints that you can purchase from a variety of science distributors. And we just put paint on them, and we stepped them across. We measured out the animal's stride, and we stepped across, and we basically created a story. We call this CSI. In this case, it's a critter scene investigation. And the purpose of this is you would lay the sheet out, or a series of these sheets out in your classroom, and you would have the students try to identify what happened. And there's three major things that I want students to figure out from this sheet. The first one is, what animals are they? How many animals were there? Because there might be more than one of a type of animal. And so if they say there's two types of animals, but there's actually 3 animals that are on there, those types of things are the things that I'm looking for. And then to the best of their ability, can they tell me what happened? Were all these animals on the sheet at the same time? Did they come at different times? Was one following another one? Were they interacting at all with each other? Or was this just some sort of random scene? Now, the great thing about this, as I mentioned, it does sort of lead, it develops those inquiry and those problem-solving skills. You create the story, but really, the story isn't as important as the skills that the students are using to get there. Okay, so I just want to test this a little bit. Obviously, this isn't to scale. You're going to have a hard time seeing it exactly, but I labeled one of the tracks. And I want you to take a quick look at that, because in just a second, I'm going to put up a poll, and I want you to tell me what animal you think it might be. Unfortunately, as soon as I open the poll, you're not going to be able to see this picture anymore. So take a good look at it. And I'm going to list there's going to be about 5 animals that are listed. All I want you to do is take a guess as to what animal you think you might be. So take a good look at that one that's marked with an arrow, that particular animal. And I'm going to go ahead here in just 1 second and open up the next poll. All right, so you should see an idea there. You should have a couple choices between a black bear, a coyote, a javelina, a mountain lion, or a raccoon. So just take a moment. It's like most people are in. We're just waiting on a couple people to take a guess. And again, it's just a guess. I didn't put anything in there for scale, so it's difficult to see that. I'm going to go ahead and close it, and let's go ahead and share the results of what you guys were thinking. And then I'll show you the picture again. So it looks like it's a tie basically between some people thought it was a coyote and some people thought it was a mountain lion, and then a few people might have thought that it was a javelina. Luckily, no one said the black bear or the raccoon. The black bear's footprint would be much, much larger, and the raccoon's footprint would be much, much smaller. So at least we're in the same ballpark. And I'm glad to see that you guys pretty much nailed at least 2 of the animals that are on here. Just very quickly, I'm going to give you the story that I used for this one. In this case, the arrow is pointing to a mountain lion track. If you at least got it down to the point where you can identify, by the time you're done here, what I really like to point out and why I like this particular sheet is that it really helps us indicate the difference between cat tracks and dog track. The other track that's on there, going from right to left across the track, is a coyote. So the fact that most people here said it was a coyote or a mountain lion, at least you're on the right track. The particular one that we're pointing to was mountain lion. A couple distinctions that you can make between coyotes and mountain lions. A mountain lion is a cat, obviously, and wild cats act very much the same way that domestic cats do. Cats are very, very direct about how they walk. They know where they're going, and they pretty much walk in a straight line to get there. And so you can see that as you start to see the track, and I'll put in a little highlighter here. As you just see, the track basically goes straight across, pretty much in a straight line. This animal was very, very direct. Okay. Now, I will tell you, based on the way that the story plays out, is that the mountain lion came through here first. Okay. The mountain lion walked through the scene first and left the tracks behind. Then second was the coyote. And I'm going to show you the coyote's track here in case you're not seeing that clearly. This one starts over here on the right, comes all the way through, and then picks up the scent of the mountain lion that walked through earlier and follows the mountain lion tracks for a little bit of time before the coyote gets distracted by something else. And then the coyote takes off this way. Now, before we talk about what that coyote was distracted by, I want to talk about, again, just like the mountain lion behaves like a domestic cat, coyotes behave much the same way that domestic dogs behave. And if you've ever taken them out on a walk, you know that dogs are kind of all over the place. They sniff a bush over here, and then they run across the trail over here to this side, and then they get distracted by the quail that's running on this side. They're kind of all over the place. And coyotes act very much the same way. So in this case, on the first part of this, the coyote is walking, and you can see in his stride, on the right-hand side, he's alternating left, right, left, right, left, right. That is that's indicative of a walking stride of a dog. And then he picks up the scent, and he's still sort of walking, following the sign, and then he gets distracted. And then from that point, he actually takes off running. And it's hard to see exactly with what you can see in this picture here, but when a dog starts to run, then they actually put 2 left paws down and then 2 right paws, 2 left and 2 right paws. So they don't have the alternating footprints anymore. Instead, they're in clusters of 2 and 2 and 2. And you start to see that a little bit, although it's somewhat hard in this. And what of course the coyote was chasing after is this last set of tracks right here, which if you could figure it out, that was actually a jackrabbit. The jackrabbit was probably just sitting there eating, and then it saw the coyote and took off running, and then the coyote chased after it. Okay. There are a couple other features that you could use to identify cats and dogs on here. I'm not going to go into a ton of detail. I do a whole workshop that gets into this a lot more, but typically cat, if you were to draw a circle around a cat, it tends to be much rounder, and a dog footprint tends to be much more oval shaped. Okay. If you were to draw a circle around the track, dogs tend to have a longer foot, cats have a rounder foot. There's also tends to be a little bit more space between the toes and the pad on cat footprints than there are on dog footprints. The back of a dog's footprint tends to be flat, tends to be a straight line, more or less. A cat tends to have these 3 lobes on the back. If you look here, it takes on sort of this lobed look on the back of their track. Okay. And the big difference between cat and dog tracks is going to be the nail marks. And if you look, I'm going to clear out the drawing here, and just let me clear out the drawing. If you look, none of the cat footprints have toenail marks. They have toe marks, but there's no toenail marks. But if you look closely, and I understand it's going to be a little bit difficult, but there are some toenail marks on some of the dogs, in front of some of the dog footprints. Dogs have claws. When they walk, they will sometimes leave those track marks, those claw marks behind. Cats, with the exception of cheetahs, will never leave those claw marks because they have retractable claws. Those claws go inside their toes, basically, which keeps them sharp because they use their claws a lot more for when they're hunting and killing. So they want to keep them sharp. Cheetahs, I'm sorry, they do not have retractable claws, and they will actually, because that helps them run, it gives them tread, and it helps them run faster. But we don't have cheetahs in Arizona, so we don't really need to worry about that. So those are some distinctions. So this is a very, very simple activity that you can bring into the classroom. These sheets, and how do you get these sheets? Well, I'm very pleased to announce that sheet that you just saw that was on the previous screen is now available in our regular Bone Box resource trunk. If you're not familiar with the Bone Boxes, these are boxes that are available at all of the Game and Fish offices around the state. So whether you're in Phoenix, we have them out of our office in Phoenix, our office out of Mesa, we have them in Tucson, we have them in Pine Top, we have them in Flagstaff, we have them in Kingman, we have them in Yuma. And then we have them spread out around the valley as well. There's one out in Goodyear, there's one in downtown Phoenix, there's one sort of in the East Valley in Ahwatukee area. So they are spread out. It's a bone box that has the skulls of 10 common Arizona mammals, as well as the hides of those same mammals. There's a number of lesson plans that you can bring these resources into the classroom, but one of the things they have is that sheet that you just saw. So the students can try to do the exact same thing that you just did and that I explained to you. Now the great thing is if they don't get it right, it doesn't matter. Again, the idea is to have them work on the problem-solving skills. And then, of course, what you do from there, you can build on it. What if you have them tell the story? So now you can incorporate some writing exercises into it and all sorts of stuff that you can do with it. You can have the kids design their own tracking sheets once they learn about the animal. So maybe they see the tracking sheet at the beginning of the unit, and then at the end of the animal unit that you've just done, they understand an animal's behavior and its natural history, and they try to create their own tracking sheet that then students have to try to figure out the answers. And they're also available in our brand new tracking box. But the tracking box is going to have all the resources that you see from today's workshop, some of the callers that we're going to talk about and some of that stuff, but it has additional tracking sheets. In addition to the one that you saw, it actually has a couple other ones in there with the stories complete on them. Of course, if you want to make your own tracking sheets, you can get the track molds yourself. You can, as I mentioned, you can buy them from just about any science supply house. We tend to buy them from like Acorn Naturalist, but I know you can get them from places like NASCO, Carolina Biological, all sorts of different places you can buy the latex tracks of different animals. We will have some available to you. In addition to the bone box and the tracking box that we have, what we've put together is a track replicas and molds kit. This is for those people that want just a whole bunch of these different replicas to use in their classroom. It also has the molds. So if you've ever, when you were in grade school or you were in Boy Scouts or any of those different types of things and you used to make the plaster of Paris tracks, well, we have the molds that you can do that with your students in as well. And we've put all those together in a box that's available that you can check out. That box is only going to be available at our Phoenix office along with the tracking box. We only have limited supplies on those, so they're only available in one location. You would contact me to get a hold of those. We can talk about those a little bit at the end. I will also send you a follow-up email that shows you how you can access all of these materials. Okay, so those are all available to you where you can actually make the sheets yourself. And as I mentioned, this is an actual lesson that we have. It's called CSI Critter Scene Investigation. That is talking about tracking sort of in the traditional method, the historical way that we used to track and that we still do it. But the great thing is, as technology improves, it makes our tracking much more efficient and effective. But I wanted to point out here that it doesn't necessarily make it easier. You still have to find the animal. And once you find the animal, you have to find a way to track it with the technology tools that you have. Typically, it's some form of tracking collar, and if you look at that picture of the elk there, there's a collar around that animal. But in order to get that collar on the animal, you have to find the animal, you have to trap the animal, you have to get the animal sedated in some way, whether you're using drugs or some other method, and then get that animal on it, all with hopefully not causing any major harm to the animal. So it doesn't necessarily make it easier, but once you have it in place, the amount of data that it collects is absolutely phenomenal. So we're going to take a look, and this uses GIS and GPS technology. If you're not familiar with this, I've done entire workshops on this as well. I'm sure I will do more in the future. GIS stands for Geographic Information System. It is basically a web-based mapping system. And if you're not familiar with GIS, I guarantee you've probably interacted with it. If you've ever used Google Earth, if you've ever gone onto the county assessor's website to look at what your house values are worth, if you've ever used MapQuest or any of those, all of that stuff is Geographic Information System, GIS. It's basically taking any sort of information and putting it to geographic data. If you've watched election coverage on CNN or Fox News or MSNBC, and they bring up these big maps and they zoom in on precincts and they can tell you how a different precinct voted, all that stuff is GIS based. It's being used in everything. There probably isn't a field today that isn't in some way touched by GIS and GIS isn't making a difference in. It's an incredibly important skill set for students to learn, so I like to highlight a lot of that stuff. And of course, then GPS stands for Global Positioning System. It is a set of satellites that are up in orbit around the Earth that allow you to collect some of this information. It allows you to locate using a device, using a receiver of some kind that allows you to get exact, roughly, pretty close to exact locations on Earth. That's the data that you can then upload into a GIS system of some kind to map your data. So let's take a look at an example of this. Well, first let's look at a collar. Again, I want you to take a good look at this collars. I included a ruler in there for scale to give you a rough idea of how big these collars were. This is basically the same collar. It goes on the same animal. It's fitted to be for the same type of species, but you'll notice that one of them is actually closed and one of them is open. We'll talk about that in just a second. But I wanted you to think about, what animal do you think this would go to? When we take a collar, the collar is designed for a very specific animal, and there's reasons for that. Anytime we put something on an animal, we don't want to affect it. We don't want to affect its survival. So we don't want to have it where it's going to get caught on stuff. It's going to be so heavy that the animal can't move. All those types of things. There are very specific rules that we're supposed to follow. In general, this is a very, very general statement. We don't want anything that we put on the animal to be more than about 5% of its body mass. Now, that's on the very, very high end, and most collars and things are much, much smaller than that. But we don't want it to be any more than about 5% of its body mass, so it doesn't really affect its survival. So the collars are specially designed for the species that we are trying to track. So it's not like you can just take a collar off of one animal and put it onto another one. So just thinking about this, look at the size of that collar, and I want you to think about what type of animal it might be. And in just a second, I'm going to open up another poll and have you try to answer. You're going to have, again, 5 choices of an animal, and you're going to tell me what type of animal you think this might belong to. So let me go ahead and show you your options now. So go ahead and take a look at the answers and select the one that you think this one belongs to. So here's the results. You can see that 45% of you said that this belongs to a bobcat, and the next highest was 36% that belongs to a deer, and then it looks like coyote and ferret, which are 2 vastly different sized animals, were rounding out third place there at about 9%. I will tell you, and let me go ahead and close this poll for you so you can go ahead and see the picture again. This collar belongs to a coyote. So very, very few of you actually got that. And that's not surprising. When I do this in person, if I did this in person, I would probably get very similar results. You have to figure that, this is going around the neck of an animal, and for many animals, they look much bigger than they actually are. By the time you get under their fur, you get under the muscle, you get under all that, all that stuff, they just look like a big animal. So when you get underneath that, and all you're doing is putting this around its neck, okay? Now let's just talk about some of these features. Now this is what we call a radio collar. Radio telemetry is a type of technique that we use. It's actually a GPS collar. We've gone beyond just using radio technology for this. And so let me point out a couple things here. I will get to show you some stuff here. So there's basically three different parts of this collar. Well, there's the collar itself, which is a leather strap, which can be cut. Obviously, we don't know the exact size of the animal, so we will cut it down once we get the animal to its location. But there's a couple different parts here. This part right here, you can see the blue arrow off to the left. That's the battery pack. Okay, this is probably the biggest limiting factor to a collar, is the battery and the size of the battery, because batteries, we really haven't found a very good lightweight storage technique to store electricity and electrical energy. The battery is the best method that we have, and it's pretty inefficient, and they're relatively heavy for what they do. As battery technology improves and energy storage location improves, we suspect that we can do more with radio collars as well. But right now, that is the battery pack. That's where the battery is stored. Now, depending on how long you need this to last, how long your research study is going to go, and how often you're going to collect data is going to depend on how big the battery needs to be and how long the battery needs to last. You can basically design these so that it turns on every so often, and you can set the interval. So maybe you only need to collect data once every 12 hours, so twice a day you want to see where this animal is. If that's the case, the battery is going to last quite a long time. If you need to see where this animal is every 2 hours or every 4 hours, and so every 2 hours is collecting data, it's not going to last as long, because the battery's being used much more often, and so the battery's not going to last as long. Typically, let's say we want this research project to last 2 years. We want to collect 2 years worth of data. What we will do is we will set it out there, and we will know that this battery is going to close out in November of 2017. Okay? So what we will do is we will design the collar to fall off in, let's say, September or October. That way, it's much easier to find the collar, because when the collar falls off, and I'll show you how it does that in just a second, when the collar falls off, it sends out a different signal and allows us to find it wherever it is, so we don't have to recapture the animal, which is really kind of cool. You don't have to put the animal through any more stress. But if the battery dies before the collar falls off, then we're going to lose all that data potentially. Now, the way it falls off is on this black piece that's right over here on the left in the middle, and also that's the part that's open on the collar right there in the middle. What happens is, at a certain time, there's a small little detonator charge in there, and it just pops off and the collar falls to the ground. And that's why you see one of these that's open and one of these that's closed. And then on the other side, opposite where the battery is, on the top left there, you can see that's basically the GPS. That's where the data system is stored on this collar. And you can also see the collar, that's the transmitter coming out there, so you can see the antenna that's stretching out. What's happening is it's sending out a signal, and this signal works much the same way that your signal in your radio does when you're listening to radio in your car. What happens is those radio waves are out there, and they're set for a very specific frequency. It's always out there, that the airwaves are out there, and you can't hear it unless you have a receiver that's tuned for that specific station. These collars work the same way. They're set for a very specific station, and then we have the receiver on our end. Okay, and I know you've seen pictures of this or videos of this with the person with the headphones on, and they're holding the big antenna up in the air. They are trying to receive the signal. So on their receiver, they tune it into the specific signal we want to find this animal, and we listen to see if we're close to it. The louder it gets, the closer we are to the animal. And that's how these things work. Now, that's to find the collar. Now, there are different types of collars. That's a basic radio collar. It doesn't store any information. We have to go out and find the animal each time, and then we record its location. But in GPS collars, their location data can be stored on the collar itself. And then we can either collect it at the end once the collar falls off. There's actually some collars now that can communicate while it's still on the animal. So once it gets within signal of a satellite or cell service, it can actually upload the data, and it can email it to the researcher, or it can send it to a special website that the researcher can log into, and they can get real-time information, more or less, of where that animal is located. So as technology improves, it actually improves our data collection methods as well. Okay? So that's the basics of these collars, and you can see here's a coyote. Now, what can we do with this? Okay, let me go ahead and clear out here some stuff, and I'll show you then what we can actually do with this data. Once we've collected a whole ton of data, we can create a map just like this one. You might not be able to see it very well, so I'm going to go ahead and explain a little bit of this, but you can see here that what we have here is each color represents a different coyote over the course of basically a year time frame. If you look at the bottom middle there, it says that this was data collected from February 21st, 2004 to February 11th, 2005. If you don't know where the area is, right there in the middle of the purple, it says the Kofa National Wildlife Refuge, and then YPG down below that says Yuma Proving Grounds. So this is rough east of Yuma a little bit, kind of in the really arid desert portion there. And you can see, so we collared a number of coyotes in this area, and we were studying their movements. We wanted to know where they're going and how they're utilizing the landscape. Now, I'm a big fan of maps. I like students to interact with maps. I like them to be able to see stuff like this, because what it does, again, we talked about building inquiry skills with the traditional tracking methods and having them build those problem solving skills and learning to identify clues, some of that stuff. So this is tracked coyotes here, and so now we can see the movements. You start to see patterns arise, and now what you could turn around is, if you handed this map to students, you can now ask them, start saying, what do you start to see? What do you start to notice? And they may start to realize that, hey, there are some coyotes, like this brown one over here, that doesn't seem to be moving around as much. Yet you have that yellow one, or the orange one, or the red one that really seems to be moving a lot more. Why is that? Okay. And they can start asking, well, maybe it's a gender difference. Maybe the females don't move as much because they tend to stay around the den site. Or maybe it's that they have more resources available to them. Their food, water, shelter is all in a better location, and so they don't need to move as much. Where those ones that are wandering a lot more need to seek out more habitat space because they can't find all the resources in one location. Maybe those are young ones, and they haven't established territory yet, so they're sort of wandering around to figure out where they want to be. Maybe those are new immigrants into the area, and they haven't figured out where all the resources are, and they're looking around. So these are all the different types of questions that students can start to ask, and we get that from these types of maps. Now, a lot of times we have the data behind that, and in fact, in this one, I do have some of the data that's available. We're not going to go over that today, but there is an opportunity for students to actually analyze through an Excel file. They can actually look at some of these data points and determine to get answers to some of those questions. But this is the type of stuff that we can collect with the callers. I'm going to go through the questions here, and we'll answer some questions. So we had a question about the bone boxes. Do they cost money to rent? No, the bone boxes are actually free to check out. The only issue is that you have to come and get them. They're loaned to you just like a library, so you have to come and get them, and you'd have to return them. So you have to come on site. They're too expensive for us to ship. They're a relatively big kind of box that stores, they can have a lot of materials in them, and so they can get somewhat expensive to ship. So you do have to come and get them. I know from our Phoenix office, we tend to check them out on Monday, and we want them back on Friday so that they're available for the next Monday to be checked out. You can check them out for longer periods of time if you need to. We particularly encourage that if you're going to use them in multiple classrooms. They're going to be sort of shared around the school. That's a great opportunity. So they are free. You just have to come and get them. Are there fake scat models? Absolutely. From the same places that you would buy the replica scat model, the replica tracks, you can also buy replica scat models. Some of them are better than others. The larger scat, things like lion and coyote, those are much more realistic. When you get smaller, when you're talking about things like a mouse, they're so small that they have to be put on a platform as well, so it doesn't look as realistic. It's not as good. We don't have many of those. There's a few of those in the track molds and replica kit that you can get, but we don't have a lot of them. We haven't used them for a lot of our programs. So for the most part, that's something that you would have to get on your own. The question, why do you track coyotes? In this case, this was actually related to pronghorn. We were studying down in this area, a little bit further south of this, when you get into the Barry Goldwater range, which is part of the military range where they test aircraft, basically live fire. They do live fire out there. There actually is the endangered Sonoran pronghorn down there, which is a subspecies of the same American pronghorn that you can legally hunt in Arizona. This is a subspecies that's found much more in the desert than the normal pronghorn that's found in the grasslands. And we were interested in studying the predators, the potential predators of pronghorn, and how they're using the habitats. And so we were monitoring coyotes in the general area to see how they're using it, to see the type of threat they were going to be for pronghorn. So this was a very specific project. We don't actually track a lot of coyotes. In this case, we were studying it to relate them back to some pronghorn predation. How often does a GPS unit send out a signal? To collect the data, we set that time frame. So if we need to have the data collected, in the case of the coyotes that you see here, I think we were just collecting it twice a day, every 12 hours. So we wanted to see where it was in the daytime and where it was at night. And so it was collecting twice a day. In the one that you're going to see in a little bit, we were actually collecting data every 4 hours. I think it might have been every 2 hours actually. And there was a very specific reason for that, which we'll explain. I don't want to sort of ruin it when we get to the next one there, but it was for a very specific reason. Now, how often does it send it to us? It kind of depends on when it comes into service. We're often using satellite, and that's an additional fee. We have to pay for a subscription onto a satellite service. And then once it comes within a range, it will often send it. Sometimes you can set them so that once a day, so in the morning you can go in and you can check to see where your new signal is. But it's really going to depend. A lot of these are in very, very remote areas, so it depends on when it can get the signal. So I answered some of those questions. So this is coyotes. I'm going to go ahead and bring up another caller here. A little bit bigger than the last one that I showed you, the coyote one. Again, just taking a note, take a look at this particular caller, note the size and how it compares to the other one, and I'm going to have you take a guess again as to what animal you think this one might belong to. Now you can see this is an old used collar. It's not used anymore. That's why we're able to have them. In fact, none of the collars that you see are still used. The cool thing about it is Telonix, a company that you can see right there on the thing, they're a local Mesa company, and they make a lot of these radio collars. Oftentimes they can recycle them, so we can take a dead used collar back to them, and they will basically put on, replace the battery, redo the leather strap and all that stuff, and then they will sell it to us back for a cheaper rate than we would a brand new collar. But in this case, our research department was done with these. They let me have them. They're not used anymore. They don't send out a signal. So this doesn't have all the bells and whistles that you would normally find. It just has the battery pack and the rate and the antenna and the collar itself. So thinking about that, I'm going to go ahead and open up the next poll, and I want you to tell me what animal you think this one belongs to. And you have a couple choices. There's a black bear, there's an elk, there's javelina, there's mountain lion, and there's wild horse. Obviously, I chose some different animals this time because it's a bigger collar. I didn't want to leave the same animals because I knew in this case nobody would guess a ferret. All right, let's go ahead and close it, and I'll show you the results. And you can see that the majority of people, 55%, believe this belongs to an elk, and then javelina and mountain lion were next, and black bear was behind that, and nobody said wild horse. I'm actually surprised more people didn't say black bear. That's often the next guess that people have is black bear. But in this case, the majority is correct. This is an elk collar, and you can't see it very well in the picture, but you can see where it's sort of faded along the end of the collar. If you wrap yourself all the way around the battery pack and down to the end of the collar, there's a little faded part. That's actually where it was locked in place. But this works much like a belt, that there's holes designed all throughout here. So once you get the animal down and you're ready to put the collar on it, it's adjustable before you start pinning those collars in place so that they can't come off the animal. Let's see some of the research that we do with elk. So this is one of my favorite maps. I love this map because of what it shows about a major wildlife issue that we have and that we deal with not only in Arizona but across the world. This is a map of I-17, the big dark black line that all those dots are sort of surrounding, that's running from the top of the screen to the bottom of the screen. That's I-17. So that's Interstate 17, north of the valley, just south of Flagstaff at an area called Munns Park. In fact, right in the middle of that big blob of yellow where you see all those black lines, that's Munns Park. Those are the roads in the community of Munns Park. So this is right by Munns Park. If you've driven up to Flagstaff, you know what this area is, okay? What I absolutely love about this map, though, is that it shows how much of a barrier highways can be. If you notice, there are very few. Each of those colored dots, again, just like the coyote map, each of those dots represents a different elk. So the colors represent a different elk. The individual dots represent specific location data of that animal. What it shows is that I-17 is a significant barrier for wildlife movement. Very few of those animals are actually crossing the highway. The green one does a little bit, the red one does a little bit, but for the most part, this highway is a barrier. And that's a significant issue for wildlife because you've just cut their habitat right in half, basically. And if their food or their water or some other resources they need is on the other side of that habitat, or as their habitat starts to shrink, they have less areas to move. Their chance of survival is becoming even less. So we spend a lot of time trying to find corridors. How can we make these highways what we call permeable and find it so that the elk and other wildlife can move through them or across them, not on the highway, because that now becomes a public safety issue for people, is if we put the animals on the highway, it becomes much harder for them and potentially deadly if you were to run into a large 600-pound bull elk. That could be serious. So trying to get them off the highway but still be able to cross through the highway. So we spend a lot of time doing that. So I love this map for that purpose. And this map is actually available in another lesson called War and Wildlife. It actually is a very fascinating article that I've tied in with the end of the Cold War and how once a lot of the Iron Curtain and some of the actual fencing that was built to block out communism, once a lot of that was torn down, the effect that had on wildlife, and there was this very unique deer species that still acted as if the barrier was there, still acted as if the fence was there long after it was gone and wouldn't cross past a certain area. And then it ties in, we bring it back home and we compare it to this map. But I want to show you a project that I'm much more familiar with that still deals with elk. This is Highway 260. And I'm not going to spend a ton of time talking about this, but basically if this is past Payson, so if you take Highway 87 out of Phoenix and you take it up to Payson to Highway 260, and then you head east towards Heber and up to Pine Top and Show Low in that area, this is the section just before you go up the rim, so just past Payson as you climb up towards Christopher Creek. This is a collection of data that we took over the course of 6 years. We had a number of elk. In fact, this was 103 different elk that you can see. So the colors are all in there. We collected almost 500,000 data points at this point. By the time this project was done, we collected nearly 1 million. But at this point, there was about 500,000 data points collected. Because we were curious, again, we're trying to figure out where elk are trying to cross. That's the whole purpose of this, is we want to figure out where they're trying to cross so that then we know where to build our crossing structures, whether they're going to be underpasses, whether they're going to be overpasses, because you can't train an elk to cross at the spot you need. You need to figure out what they're trying to do and then see if you can just use their natural behavior to the benefit and get them across the road. Now, this is a case where we had these collars activated to collect data either every 2 hours or every 4 hours. I don't know the exact time frame, but it was a much shorter time than the coyotes you saw, because the purpose was we're trying to figure out where they're trying to cross. If we had a huge time frame of 12 hours and we had a data point on one side of the highway and another data point on the other side of the highway, it would be very difficult to figure out the exact location where they cross. If we bring that time frame much smaller to 2-hour time break and we have a data point on one side and a data point on the other, it's a lot easier to extrapolate the approximate location of where they crossed the highway or where they tried to cross the highway. So in this case, we brought that research down up to a very specific time frame so that we could study this. Now, what can we do with this? So we've mapped the data, but we can do more with it. We can actually try to figure out, based on that data, where they were trying to cross, which was the purpose of this. And you can see here, this is that highway, this is that stretch of highway broken down basically into quarter-mile segments, give or take, actually 1/10 of a mile segments of this 17-mile stretch of highway. They were broken into 1/10 of a mile sections, and we tried to say, where are they trying to cross? That line, that dotted line that you see running down the bottom, that basically is saying, if everything was entirely random, all of them would be trying to cross at this level. Clearly, that's not the case. There are certain areas where they are trying to cross more than others. So we look at those peaks, and that's where we try to figure out, where do we build the crossing structures? Is it possible to build crossing structures here? Because sometimes it's not possible. The topography of the area, what's in that area may not allow us to build a crossing structure, and then we have to look for other solutions. But if we know they're trying to cross in these, let's say we have 4 really big peaks, it looks like, and then a couple secondary peaks. If we can build in those areas, we can minimize the amount of structures we have to build, but maximize the amount of crossings. And that's ultimately our goal, because these crossings aren't cheap to build. Okay, so if we can figure it out, so we're able to do this with the data that we collected. Okay, let me do questions here. Are there old GPS collars in the bone boxes? Not in the bone box, but in the tracking box. These actually the exact collars you've seen pictures of, these are the ones that are in the tracking box that's available from our Phoenix office. So these collars are available. You can do the same activity. You could actually have the collars out, and the kids could try to figure out what animal they might go to. You'll be able to hold them. You'll be able to do all that stuff with them. Are there fences around the I-17 in that location? We do put fencing along the road, and that it's called funnel fencing. And the idea is that when the elk approaches, they hit the fencing, and then the fencing is supposed to guide them to those crossing structures. It's not always effective because at some places you can't have fencing, like where there's intersections and things like that, you can't have fencing. You can try to do some other things like cattle guards and stuff like that, but they're not entirely effective. But yeah, we do put fencing up, and they're specially designed fencing. Are there any plans to create the wildlife bridges similar to the ones up by Vegas? We are doing those all over the place. The Vegas ones are ours. There's 3 up by Vegas. If you don't know what they're talking about, we have these 3 bridges just before you hit the Arizona-Nevada border, and you cross over the Colorado River. There are 3 bridges. If you were to look at them, you would realize that there's actually no road on them. Those are bridges designed specifically for bighorn sheep. That works because bighorn sheep like bridges. In the case of the on 260 that you just saw, the elk, the bridges aren't as practical because of the topography of the area, but we can build underpasses. The road, they can go under the road, but then we have to build very specific structures under there that they will use. We're also building one outside Tucson right now, right near Oracle. Because of the bighorn sheep that we just put back into the Catalina Mountains, there's a crossing structure being built for them outside Tucson. There's a number of these crossing structures being built all across the state. Some are in planning phases, some are being built right now. The structure depends on the species that you're trying to do. Doesn't mean that other animals won't use those crossing structures, but we are designing a crossing structure for bighorn sheep up near Vegas, for example. We're designing the crossing structure for elk out by 260 because that's the dominant animal. That's the problem species, for lack of a better term. Other animals will use them, but they are designed for specific animals because different behavior, different natural histories mean that they're going to use that they have different requirements when you build a bridge. And then we had, on my way back from the canyon, we saw what I thought was a California condor on top of a dead elk, ripping meat from it. It was amazing. Yep, there are condors up there. I can't say for exactly whether it was condor, but obviously there are condors up in what are called the Vermilion Cliffs out near Page, and then they do come into the Grand Canyon. It's actually quite common to see them in the Grand Canyon depending on the time of year. They've actually become a pest in some parts of the Grand Canyon where the rangers are trying to sort of scare them off so they don't become accustomed to being around people. It very well might have been a condor. It also could have been a vulture, just kind of depends. If it had the red head, that's indicative of a turkey vulture. If not, it could have been a black vulture or else a California condor. California condors are obviously very, very big, but it's possible. It's really neat to go over there and see them. The other indication of a California condor is if you have a chance to see its wing is going to have a numbered tag on it. All of our condors, unless they're wild born, are going to have that numbered tag on its wing that helps identify it. Doesn't it seem like they are crossing all over that highway? They are. You're correct. They are crossing. They're trying to cross all over, but there are some very specific areas that we're trying to do. So what we would do is we would try to utilize, again, that funnel fencing and try to put in some structures in here. Now, I should say that over this, I think it was a 17 or 18 mile stretch of highway, there are actually 16 underpasses that are more or less designed for wildlife or that are wildlife friendly underpasses. So there was a lot of work that needed to be done because it's such a high population of elk in that area. Where did you end up building the elk crossing based on the crossing segment data? There were a number of places, and I actually have a whole series of 3 activities that delve much more into this, and you can see where a lot of those crossing structures are. The interesting thing up there, and we are starting to run out of time, so I'm going to just do this very, very briefly. If you drive up there now, the only evidence that you see of these, other than the bridges that you drive over that you don't even know you're kind of driving over in some cases, there is an elk crosswalk up there. And it's just on the westernmost side of this, so it's the closest side to Payson. You'll go to an area that says elk crossing test area or something like that. It's actually at the end of the project. So it would be on near the 0 or the 20 in the lower left-hand corner of this. It'd be on that side of this map. It's just as you enter this, and it was the end of the project, so the side closest to Payson, the highway hadn't been improved, and so we needed to put some extra remediation effects in there. Otherwise, we were going to see an increase in hits at that area that we hadn't had a chance to work on. So we developed an elk crosswalk, which actually uses some military-grade software, some thermal imaging, and detects whether there's an elk there. And the purpose is that it actually warns drivers that there's an elk on the highway so that the drivers slow down. And that's one of the solutions that we've utilized in that area. And you can actually see that. You don't always see it going because it's supposed to only go when there's elk on the highway or near the highway. It does last for a few minutes, so the elk, by the time you get to it, the elk might be long gone, but it is up there. It's really cool to see. So I'm going to go ahead and move on here, and we're going to do one more collar, and then I want to talk very quickly about another lesson that I have. So again, look at this. This is not a collar in this case, but it is a tracking device. Look at it, look at its features, look how it's different than the other ones, look at the size, and think about what animal this might belong to. And then in just a second, I will show you this poll. Which of these animals do you think that belongs to? Does it belong to, or would it go on an alligator? Would it go on a mallard, which is a type of duck if you're not familiar? Would it go on a river otter? Would it go on a tortoise, or would it go on a turkey? All right, I'm going to go ahead and close it, and I'll show you the results. You can see that it's pretty evenly split. A third of you thought it was river otter, and a third of you thought it was tortoise, roughly a little bit less than a third on both of those. And then a little bit more thought it was a turkey. I'm glad to see nobody said it was an alligator. We don't have alligators in Arizona, so Arizona Game and Fish would not be tracking those. And that's a little bit big for a mallard, probably. It does belong to a bird, though. This is actually what we would use. It's a turkey backpack. And those loops would actually go through, the wings would go through there, and it would actually wrap around the wings and be a backpack on the bird. You can see it has a very different tracking technology. For a tortoise, which there actually is a tortoise tracking device in the box that you would get, I just didn't include it here, actually doesn't have any straps or anything. We actually glue it right onto the shell. And I actually haven't seen a river otter one. I'm guessing it would be similar to a collar, but it would be much, much smaller. And we'll move on a little bit. So I don't have a lot to talk about turkeys. I don't have a lot of data. I just wanted to show that one in here. But the next one that I want to do for the next just a couple minutes, I'm going to run through this very, very quickly because I did say this was going to last an hour. So fish present another whole problem with how we track them. You can't put a collar on them because nothing's going to say. You have to make whatever you put in there waterproof. So what we have to do on a fish actually is it's much more invasive. It's what we have a pit tag that actually goes inside them, and that's what you can see here. The fish is still live at this point. We've actually cut them open a little bit. We put this little receiver inside, and then what all you see on the outside basically is a little antenna that sticks out of the fish. And then this fish goes back into the water after it's been cleared up with some antibiotics and a number of other things. It goes back in the water, and we can track it. We actually have to go on a boat and actually stick our receiver into the water, and we actually listen for the beeping in the water. It's actually kind of a cool little process, but obviously it's a little bit more invasive. It is more invasive, a little bit more dangerous on the fish, and so it's not quite as clean and nice as it is with some of the other ones. But there's a reason we're doing this. And this is a whole activity you can get. I'll tell you again, this hasn't been written out as a full lesson, but you're going to see all the documents you have here. But this was a very specific problem. Lake Pleasant is a premier largemouth bass fishery. And over the past 15 years or so, we've been noticing that the largemouth bass production has been declining. It's been thought that it might be the result of a recent invasion of striped bass. And so a lot of the bass fishermen were concerned about this, so they approached us and we began a research project. Just to give you an idea, this is Lake Pleasant. If you're not familiar, it's sort of north of the Phoenix area, northwest of the Phoenix area. You can see it in the map there. You can see it's created from the Agua Fria River. The Agua Fria River comes in from the northeast, sort of winds around. The dam is down there on the south side, and that's what creates the Lake Pleasant area, the Lake Pleasant. The CAP Canal actually connects to it. Runs from the CAP Canal actually goes all the way from the Colorado River, but it connects to Lake Pleasant and then continues on into the valley. So here's some background. We know that the striped bass came into the canal system. The CAP canal system is eggs from the Colorado River. And then in 1992, the canal was hooked up into Lake Pleasant. And shortly after that, striped bass were discovered in Lake Pleasant. As a result, we required them to put on special anti-fish measures that would keep if there were striped bass in the canal system, to keep them from coming into the lake. We thought that was working. In addition, we really didn't think it was that much of a problem because all of the literature that was out there said that a situation like Lake Pleasant was not suitable for reproduction of striped bass. So any fish that were in there were coming in from the canal system, but they weren't reproducing. That was largely what was thought. However, we seem to see that the population is increasing in Lake Pleasant, so the question is, how is that happening? Are they actually reproducing in the lake, or are they still just coming in from the canal, and the anti-fish measures that we have in place to block those fish from getting from the canal into the lake just aren't working? And that was an important thing because that determines what your how you're going to deal with the problem. And so you present this problem to your students, and then there's actually 3 questions we were trying to answer in this. The red one is the one that we're talking about here, are striped bass reproducing in the lake system. And interestingly enough, it doesn't seem very intuitive, but that's the one that we can answer using tracking. And it's because of fish biology that we'll talk about in just a second. But there were 2 other questions that we were trying to answer. One, are striped bass still getting into lake from the canal? So we need to determine that if we need to put up other preventative measures. And are striped bass a competitor of largemouth bass? So the issue was spawned because they thought that largemouth bass was declining because of striped bass. So what we needed to know is, okay, if they're in there, is it really a problem? Because do they actually compete, or are they hitting a different niche? So there were 3 questions we were trying to answer with those. What I would do with students then is turn that around and say, okay, how would you answer these questions? What type of data would you need to collect? And you can go through it, and you'll get the research report that shows how we went about doing all this stuff. With the competitor, what we're going to do is we're going to do stomach samples. So we're going to catch the fish, we're going to cut them open, we're going to see what's in their sample, what they're eating, to see if they're competing with each other, stuff like that. So there's different types of things that we do. But for the reproduction one, we're actually going to use telemetry. And so here's some stuff that we know from the literature. So just like your students do sometimes, and they have to do background research, our biologists have to do the same thing. So we learned a lot of different things. We know that adult striped bass have a very specific temperature tolerance. We know that they spawn at a very specific temperature. We know that in the other parts where we see striped bass, they start spawning between April and June. And then striped bass broadcast spawn their eggs, which basically means they shoot everything out into the water. And there has to be turbulence where they can remain suspended. They don't want their eggs to sink to the bottom. So with this information, it gives us a lot of information. We know that when they're spawning, they're going to be looking for turbulent water. So you have to start thinking about, in a lake, like Lake Pleasant, where would you find the turbulent water? And then it has to be during a certain time of year, and it has to be at a certain temperature. So given that information, we can actually try to figure out if they're reproducing. So this is the activity that your kids could do. I'm not going to have you do this today. We're going to look at it briefly. But what we did was we have one fish that we actually have more than one fish, but this is data from one fish that we track. And it shows, and what I would do is I would give the kids the graph on the right with a blank map of Lake Pleasant, have them map the information, and then they would try to figure it out. And what you start to realize is, okay, during a certain time of year, the fish are moving up into the river. Why are they doing that? Well, that's typically where they're going to find the turbulent water. The temperatures are going to be it's going to be a different temperature regime. So they have to try to figure out, does it match what it does? And it's not going to be perfect. That's the great thing about this, is it's not going to be perfect. But in the end, what you do is you can give your students the same research, our final research report. And this is what I think is so cool about this activity, is it's so empowering, because the kids can realize that they can have the same data that scientists have, and for the most part, they're going to come up with the same conclusion. And what you see, if you were to read this, and I don't expect you to read it all right now, but actually in there, it does say that it's likely, given the data that we provide, it's likely that they're reproducing. And in fact, in the picture that's in the middle there, there's a circle there. That's the likely spawning area for striped bass. Now, the problem is, because they broadcast spawn, we can't exactly prove directly that they're reproducing because we can't see the eggs. But given the evidence, it seems the indirect evidence shows that they're most likely reproducing. So given all the background research that was out there that said that Lake Pleasant, or a lake like Lake Pleasant, was not appropriate, does not have the right conditions for spawning, we've actually found that they most likely are reproducing in the lake. So that's where those other questions that we had to answer, like, are they competing with the largemouth bass, now become important. Because are you going to be able to get striped bass out of this lake if they're reproducing? I don't know. If it was just a situation of coming in from the canal, we could probably institute other measures to keep them out. But if they're reproducing in this lake, it's going to be very difficult to get them out of the lake. So now we have to figure out if they're competing. So that's where these multiple parts of this research project come in. So there are a couple questions. Are striped bass indigenous to the U.S.? How is the drought affecting Lake Pleasant's wildlife? I can't speak directly for Lake. I do know that Lake Pleasant, at times is very, very low. I haven't been out there since March, so I haven't seen what it's been like lately. Striped bass are indigenous to the U.S., but they're not indigenous to Arizona. They were introduced as a sport fish. So you can fish them in certain parts of Arizona, but they're not native to Arizona. We brought them in as a sport fish. They're actually a fish that in many parts of the country are both saltwater and freshwater. They will spend some of their time in saltwater, and then they'll come up into the rivers to reproduce. That was largely why they weren't thought to be able to reproduce in Lake Pleasant, because there's not that saltwater element. What predator eats striped bass spawn? Probably other types of fish. I'm not quite sure directly. I'd have to go in and see some of that stuff and what we're doing. Obviously, there's going to be some other stuff in there but other fish are going to eat the spawn, anything that can get any other sort of spawn-eating ones. But it's going to have to. The tricky thing is are the fish that are in Lake Pleasant, does their spawning cycle match up where they're going to be eating the spawn, because usually it's going to be the babies of those fish that are going to be eating them. So are they being born before the striped bass are spawning so that they can use the fish as a food source, or are the striped bass spawning first so they're feeding on the other fish? This really starts to get really, really complicated. So that is all that I have as far as this presentation goes. I appreciate it. I appreciate you guys coming out. Feel free to contact me with anything. Thank you.